everyone, welcome back. This is lesson 10-2, circles. The objectives for today: by the end of this lesson, you'll be able to write an equation for a circle, and you'll be able to graph a circle and identify its center and radius. The vocabulary for today is tangent and circle. A circle is a set of points in a plane that are a fixed distance called the radius from a fixed point called the center. So this is something that you already know. If I have a fixed point and I have a radius, these are all going to be the exact same distance, and mine is obviously not perfect, but you get the idea. This is our center, this is our radius. Because all of the points on the circle are the same distance from the center of the circle, you can use the distance formula to find the equation of a circle. All right, so the first example, we're going to use the distance formula to write the equation of a circle, and we're given the center and we're given the radius. So let's use the distance formula, and here you might remember it. And all we need to do is just replace a -3 into our x1 and the 4 into our y1. We don't know what the other points are, but we do know that our distance of the radius is 6. So we're going to just substitute all those points in with information that we know. And now we actually, if we square both sides, we actually have the equation of a circle. Let's go ahead and finish it out. So 36 equals x plus 3 squared plus y minus 4 squared. And there you go. So try this one on your own. Hopefully you can do the exact same thing. Turn your video off for just a second and give it a try. All right, so the first thing that we want to do is go ahead and use the distance formula, and here it is. Again, we're going to substitute our x into the x place and our y into the y, and we have the radius, so we know the distance, so we'll substitute that into our d. And once we substitute everything in, we can just square both sides now so we can get rid of our radical. And go ahead and square out 7 squared equals 49. So here's your equation. Hope you were able to find that one. So notice, let's take a look at what we can see here. R squared, all right, and the center are visible in the equation of a circle. This leads to the general formula for a circle with center HK. So if our center is HK, we can do that with any, as long as we have this information, we can write our equation. And here's a little chart that might help you. You can find this in your textbook. It's going to be found on page 729. And so this is just, again, just showing us what the equation is. So this is the equation of a circle with center at HK, and the radius is R. All right, so here's your equation. Here's one with actual numbers in it, and here's what it would look like on the graph. All right, here's a helpful hint. If the center of the circle is at the origin, the equation simplifies to x squared plus y squared equals r squared. All right, here's a new example, writing the equation of a circle. So this time, we have the circle with a center of 0, 6, and a radius of 1. So now we just need to know the equation of a circle, which happens to be right there. So all we have to do is just go ahead, our x component goes in the x, our 6 can go in here, and our radius can go there. And when we substitute that all, and then multiply our 1 out, we have our final answer. So there's our equation of a circle. All right, here's another one to try. This time the center of the circle is at -4, 11, but this time they didn't give us the radius, they just told us another point. All right, so what we're given now is we're given a center and we're given a point. So we're going to have to find the radius by using, what do we have to use? We're going to use the distance formula to find that radius, okay? So we need to find our radius before we can write our circle. So let's use our distance formula. And we're going to go ahead, and this time we have an x and a y and an x and a y. So let's put our x in and our x and our y's together. And notice that it's subtraction, okay? In our distance formula, you're subtracting both times. All right, so once we have that all filled out, we don't know what our radius is, but we can go ahead and actually solve this. 5 minus a negative 4 is actually the same as 5 plus 4, which would be 9 squared, plus negative 1 plus a negative 11 is 12. So we're going to have 12 squared. All right, and let's go ahead and work that out. You end up with 225 equals 15. Square root of 225 and equals 15. So now we know that our radius equals 15. Now we can easily use our formula. So substitute the values into the equation of the circle, and there it is. So we can just take our center again, which is negative 4, and notice that this, even though this says negative 4, we have a plus here because the equation actually says x minus 4, like this, and y minus here is 11. So minus minus gives us our plus 4. Pay attention to that when you're working on those problems, that your equation actually is a negative, a minus sign there. And finally, once you multiply everything out, you get your equation of your circle. Not a problem. All right, here's one for you to try on your own. Turn your video off and give it a try. Again, we're to find the equation of the circle with the center at negative 3, 5, and containing the point 9, 10. So what we have so far is we have a point and a point on the circle, and we need to find what that radius is so we can fill it into our equation of a circle. So in order to do that, let's use our distance formula. Remember, this is going to be our x1, y1, and x2, y2. Here's our distance formula with everything substituted in. And when we multiply it through, we find out that r equals 13. Now, all we have to do is substitute the values into the equation of a circle. And remember, it's going to be x minus h squared plus y minus k squared equals the radius squared. All right, so and h and k are going to be the center points of our circle in this case. So once we go ahead and square out 13, we end up with x plus 3 squared plus y minus 5 squared equals 169. And notice, since we subtracted this, we just have to see that our center is going to be x equals negative 3 and y equals 5, which is what we had to begin with. The location of points in relation to a circle can be described by inequalities. The points inside the circle satisfy the inequality x minus h squared plus y minus k is less than r squared. The points outside the circle satisfy the inequality x minus h squared plus y minus k squared is greater than r squared. Let's look at an example to see how that might work. Here's an example. It says Raul and his friends are deciding where to have a pizza party based on the delivery area of the pizza restaurant. The restaurant is located at the point -1, 2, and the letters represent the homes of Raul and his friends. Which houses are within a 3-mile radius of the restaurant and will get free delivery? All right, so we're going to assume that each of these little marks is a mile. All right, so first of all, we need to graph the circle with the center at -1, 2. So here's -1, 2. So here's our restaurant right here. And the radius is 3. So what you're going to do is choose 3 points just on the vertical and horizontal. 1, 2, 3 right here. And then we're going to go 1, 2, let's see, 1, 2, 3 right here. And 1, 2, 3 over here. So now you can kind of graph in what your circle is going to look like. And you can see a little bit better from the picture down below here. what it actually looks like, but I wanted you to see how to get that idea. So once that we've done that, the points inside the circle will satisfy the inequality of that this is less than 3 squared. So just looking at it, we can see that D and B are within the 3-mile radius. All right, but we have some other points. Look how close C is. Did I make a mistake there, or should C actually be in that radius? Well, I'm not exactly sure, but it doesn't really look like it. So let's just check that point. So we're going to fill in our X here, okay, and our Y here. And when we solve it all out, we see 1 plus 9 is less than 10. And we know that's, or 9, 10 is not less than 9. So we know point C is not inside the circle. All right, here's another example. It says, which homes are within 4 miles of the restaurant located at -1, 1? So let's go ahead and get our restaurant located here, and let's go 4 miles. So 1, 2, 3, 4. 4 miles north, 1, 2, 3, 4. 4 miles west, 1, 2, 3, 4 miles south, and 1, 2, 3, 4 east. All right, so when we go ahead and draw our circle in, we can see pretty clearly what houses are going to be available there. So the circle has a center at -1, 4 and a radius of 4. The points inside the circle will satisfy this inequality. Points B, C, and D do appear to be within that range. All right, let's see, there we go. But let's talk about something else. Let's talk about point F. It seems to be outside, but I just want to make 100% sure. So point F is found at -2, 3, so we could just fill that in and substitute in to our equation. And when we do that, we find that 1 plus 16 is less than 16. No, that is not true. So that tells us that point F is not inside the circle. And I just want to point out again, this is our center that they originally gave us, okay? All right. All right, so try this one on your own. It says, which homes are within a 3-mile radius of a restaurant located at 2, -1? Turn your video off and try it. Okay, so the first thing we needed to do is locate our restaurant. We're going to go over 2, down 1. So here's our restaurant. And we need to have a 3-mile radius. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So when we draw our radius and draw our circle, here we go. It's kind of messy, but that's okay. And we want to know which houses are in there. So it looks to me like C and E are the only houses that made it inside our boundaries. And sure enough, points C and E are within the 3-mile radius. Now we could also check. So let's check point B because it's pretty close here. All right, point B is located at 1, 2. So we're going to write our equation of a circle. All right, here was our center, 2 and -1. And we're going to fill in our new point and check. And when we do the math work on it, we see that 1 plus 9 less than 9. No, that is not true. So point B is not inside the circle. All right, a tangent is a line in the same plane as the circle that intersects the circle at exactly 1 point. So let's talk about a tangent. Recall from geometry that a tangent to a circle is perpendicular to the radius at the point of tangency. All right, so, and when it's perpendicular, that tells us that there's a right angle there. All right, so let's talk about a few things that we need to know about this. The tangent is perpendicular, so the slope of this tangent right here is actually going to be opposite the slope of our radius, all right? And so we're going to be trying to find the equation of this line, this tangent line right here. All right, so here we go. We're going to write the equation of the line tangent to the circle at x squared plus y squared equals 29 at the point 2, 5. So let's think about what that's going to look like now. All right, so first of all, we want to identify the center and the radius of the circle. All right, so from this equation, notice x squared plus y squared. Remember that told us that the center is actually going to be at 0. All right, and with our equation, it says, our distance equation says that the radius now is going to be the square root, because remember, when you're using the distance formula, we have to take the square root of both sides. So our radius is actually the square root of 29. All right, and remember, square root of 25 equals 5, and square root of 36 equals 6. So square root of 29 is somewhere between 5 and 6, just as a point for you to notice. So let's review what we know so far. So far, we have been given the center at 0, 0. And we know that we're going to have a line tangent at 2, 5, so over 2, up 5. So it's actually going to be somewhere here. My picture isn't quite as accurate. So we're given, let's see if I can get that right. All right, and there's our tangent. So remember, we're still looking for the equation of this line. All right, but we do know now that by using our just information that we have, that the radius is going to equal square root of 29. All right, so step 2, we're going to find the slope of the radius at the point of tangency and the slope of the tangent. So let's use the slope formula because we know 2 points. We're going to know that the center is at 0, 0. And we know that this point is going to be 2, 5. So in order to find our slope, we just put it in the difference of the y's over the difference of x's. And when we substitute that in, we find out that our slope of the radius is 5 over 2. So slope of the radius is 5 over 2. Now don't forget that if the slope is 5 over 2, the slope of the tangent, because it's perpendicular, because of it being perpendicular, the slope is going to be the negative reciprocal. So the slope of the tangent is going to be negative 2 over 5. Negative 2 over 5. It's the opposite reciprocal. When we have opposite reciprocals, we have perpendicular lines. All right, so now that we know that information, we're going to go on to step 3. We have to find the slope-intercept equation of the tangent by using the point and the slope. So fortunately, we have a really easy equation. I hope you remember that. It's the point slope formula, and it's just right here. So this is a really great formula to have for you to have memorized now. All right, so we're just going to go ahead and substitute 2 and 5 into our x and y, and then we're going to use our new slope of negative 2 over 5. So substituting that all in, we end up with we can rewrite it into the slope-intercept form just by adding 5 to both sides and then distributing this all out. And when we finally do, we get y equals negative 2 over 5x plus 29 over 5. All right, and to finish it out, the equation of the line that is tangent to x squared plus y squared equals 29 at 2, 5 is right here. Y equals negative 2/5 x plus 29 over 5. And again, you can always graph these out to check and make sure that this line is actually tangent. Remember how to get that into your calculator. You have to solve for y first. So you would have to subtract x squared from both sides. So then you would have y squared equals 29 minus x squared, and we have to get rid of this, so we're going to take the square root of both sides. So you would actually put in your calculator y equals plus square root 29 minus x squared over and minus, plus or minus that. Okay, next. All right, so try this one on your own. Turn your video off and give it a try. All right, let's take a look at all the information that we have. It says write the equation of the line that is tangent to the circle. So we're trying to write the equation of this line right here. All right, and it's going to be at point 5, -5. So by looking at this information, we can identify the center and the radius of the circle. So the center is going to be at 1 and -2. And the way I always look at this is I just say, what number makes this whole piece 0? And that would be 1. What number makes this whole piece 0? -2. So our center is at 1, -2. And we also know the radius is 5. So let's go ahead and write that information in. This is at 1, -2. This point is going to be 5, -5. And we know our radius is going to be 5, so we know our distance. But what we need to know is we need to know the slope, because remember, to write the equation of a line, we're going to write y equals mx plus b, and we have to know what that slope is. So we're going to need to find the slope of this line. So for step 2, we're going to find the slope of the radius, and then we'll at the point of tangent C, and then we'll find the slope of the tangent. And remember, the slope of the tangent is going to be the opposite reciprocal because they're perpendicular to each other. So the first thing we're going to do is go ahead and use the slope formula. Remember, it's the changes in y's divided by the change of x. All right, so let's go ahead and substitute. We know we had one point at 5, -5, and we had our other point at 1, -2. So substituting that in, we find out that our slope of the radius is -3/4. All right, so knowing that, we now know that the slope of our tangent line is going to be the opposite or negative reciprocal. So if it was -3/4, the tangent of our new line is going to be 4/3. Next, all we have to do is fill this into our point slope formula. And that is a very easy formula for us to use, so let's remember what it is. The point slope formula is written here, y minus y1 times the slope times x minus x1. So our y's are going to be right there. My x is right there. So let's go ahead and substitute that in. And when we do that, we see y plus 5 equals 4/3 times x minus 5. And now we just need to make sure we go through and distribute these two pieces. And then we're going to subtract 5 from both sides. And when we do all of that, we end up writing it in the slope-intercept form because we solved for y. And here is your final answer. So I hope you were able to find that just fine. All right, the equation of the line that is tangent is right here. We just found that. And again, let me remind you, here's the equation of our line. If you want to put it in your calculator, you're going to have to solve it for y. So remember all the steps that we would have to do. Subtract x minus 1 squared from both sides. So we have 25 minus x minus 1 squared equals y plus 2 squared. And now we have to get rid of that, so we're going to square both sides. Hope you remember all this. And then we have 25 minus x minus 1 squared equals y plus 2. Subtract 2 from both sides. And so then we have 2 plus or minus. So you have to grab both pieces. Minus x minus 1 squared. And you'll have to graph both of those to get your complete circle, and then you can graph your y, and you should get something that looks like this. All right, so that is the end of the lesson. Here's some quiz questions for you, so you can turn your video off, and I will show you the answers in just a minute as soon as you've given it a try to make sure you understand this. All right, so to write the equation of the circle with a center at 1 and -5 with a radius of 10, that was pretty easy. So remember It's just x minus 1 plus y minus a negative 5. And this was equals r squared. And so if we had square root of 10, that means square root of 10 squared is actually equal to 10. All right, write an equation for the circle with the center at negative 4, 4 and containing the point negative 116. And there it is. I'm not going to work it all out for you. If you need questions for that, you can watch the video back at that section again. All right, and here's one more for you. Which points on the graph shown are within 2 units of the point 0, negative 2.5? So turn that off and do that real quick. Okay, so let's take a look at where that point is. 0 over 0 down 2.5. 1, 2.5. All right, so here's our point, and we need 2 units. So we're going to go 1, 2. Here's that direction. 1, 2 this direction. 1, 2 this direction. And 1, 2 that direction. So here's our circle. And you can see that the points C and F are within there. So your answer is C and F. All right, and finally write an equation for the line tangent to the circle at 0.41. So here's your answer. Sorry, I went a little bit fast on that. You can turn your video off and give it a try to make sure you got it right. All right, and that is the end of lesson 10-2, circles. I hope you have a great day, and I will see you in class tomorrow.